This lecture is based on Karnataka TET syllabus. Chapter is How Do Things Work? From that subtopic is light. In light, I am going to cover reflection and refraction in this class. Hello friends, welcome back to my YouTube channel Unfog with Dr. Atahar Parveen. So before starting the class, I would like to give you few tips so as to how to prepare for this particular chapter. This is a very important chapter, and because this is a logically based chapter, you need to understand the concepts logically and very carefully. I would request you all to please watch this video very carefully right up till end, because the next part of this chapter, which I am going to post soon, will be based on this lecture only. Okay? So whatever I am discussing in this class, you have to carefully listen, make a notes and try to understand in a clear way so that you understand the next part of this chapter easily. And in next part, I am not going to discuss those concepts which I am teaching here in this class. I will assume that you all know and then I will have to proceed. Then only we can finish the syllabus as soon as possible. We know the exam is on head, right? So we need to finish the syllabus as soon as possible. Okay, without wasting our time, let's start with what is light. Light is a form of energy that enables us to see things. And how are we able to see things? When light starts from a source and bounces off objects, our eyes perceive the light and our brain processes the signal, and eventually it allows our eyes to see the things. And light has few properties, right? They are the well-known properties. The first is that light travels in a straight line. This is also known as the rectilinear property of the light. Now make a point that light travels at speed of 3 into 10 to the power 8 meters per second, which is very much faster than that of sound. This can be a MCQ question. Next is light can be reflected. There is a possibility of refraction of light, dispersion of light, diffraction of light, polarization and interference of light. In Karnataka TET syllabus, in science, they have given only reflection and refraction under light. So, we will discuss only those two topics in this lecture. Rest part, the mirror and the lenses, I will take 2 more classes to finish that part. Okay. So, let us try to discuss reflection first. Now, what is reflection? Light starts from a source and bounces off objects, or you can also say that light starts from a source and it is traveling in one medium. Then it bounces off when it is incident on the surface of another medium. This is known as reflection. Here you can see that this is a plane, some plane slab or something, some solid it is, but it is plane. Okay. Now, one light is initially falling on it and then it is getting reflected. Now, the light ray which is initially falling is known as incident ray, and the light ray which is getting reflected is known as reflected ray. It is bouncing back here, right? The incident ray, after it touches the surface of this plane, it bounces back. This is known as reflected ray. There is one more line which we call as normal. We draw it perpendicular to this plane surface. This is the normal to the surface. And this is a very important line. This is an imaginary line, but it is very important because we are finding the angle of the incident ray with respect to the normal. And that angle is known as incident angle. And the angle which is made by the reflected ray with respect to the normal to the surface is known as reflected angle. Okay. Now, whatever this reflection happens, it is based on two laws. They are known as laws of reflection. The first law is that the angle of incidence equals the angle of reflection. Always. Whenever reflection happens, it follows this law that the angle of incidence, here theta I, is equal to theta R. The second law states that the incident ray, the reflected ray and the normal to the surface, all three of them lie on the same plane. And the two rays, the incident ray and the reflected ray, they are on opposite sides of this normal. Okay, these two are the laws of reflection. Now, consider that this slab is a plane mirror. What happens in a plane mirror? Imagine if you are standing in front of a mirror. Here I have kept a candle. Imagine that you are standing here in front of a mirror. Then you can see your image, right? You can see your image in the mirror. Now what will be the properties of this image? See, now because I am giving an introduction about this chapter, I am going in detail. Now further I will assume that you know all these things. So that's why please watch it carefully. Okay. So when we are talking about the properties of image in a plane mirror, we are telling about these four properties. What are these four properties of the image formed? The first is the virtual and erect image is formed. What do you mean by virtual? Virtual is that something which you cannot touch or which you will just have to imagine. You cannot touch. Can you touch the image in the mirror? You cannot touch, isn't it? Actually, that image which is formed here in the plane mirror is formed with the light rays which appear to meet. Behind the mirror, there are no light rays, right? There are no light rays. We are extending these light rays which are reflected. These are the imaginary extended lines. And then where they appear to meet, there you are finding the image. That's why we call this type of image which you cannot touch or which is formed by the light rays which are appearing to meet, which are not actually meeting. They are the imaginary lines. Okay, that type of image is known as virtual image. So in a plane mirror, there is a virtual image and it is erect. Erect means straight. This is the first property of the image formed in the plane mirror. What is the second property? How does the image look? The image looks same as the object. The size of the image is same as the object. There is no change in the size of the image. Third is that the image is formed is as far behind the mirror as the object is in front of it. You must have noticed, if you take something very near to the mirror, then the image appears to be very far in the mirror. So that is the property of the image formed in the plane mirror. And the last and the most important property of the image formed is that it is laterally inverted. What do you mean by laterally inverted? For example, if you are taking a poster written as no in front of the mirror, then your no looks like this. So this no looks laterally inverted in the image. So these are the properties of image formed in the plane mirror. Okay. Same thing we are going to do with the spherical mirrors and lenses also. There are three things, right? Even in your syllabus you can see. I am taking an example of the plane mirror just to make things simple and make you understand. So that in the further difficult stages, things become easier for you. So I am talking about mirror now. Same things like the properties of the image which I have showed here. Same things we are going to describe for the spherical mirror as well. Okay. So let's proceed. One more thing which I have to discuss here is the glancing angle. This is the angle between the incident ray made with the plane of the mirror. You denote it by G. Okay, small g. So along with angle of incidence and angle of reflection, you should know what is glancing angle. Okay. After knowing what is angle of incidence, angle of reflection and glancing angle, we should also know what we call it as angle of deviation. Angle of deviation means it is the angle between the incident ray and the reflected ray, or the incident ray and the deviated ray. Okay, so this angle of deviation we denote it by Greek letter delta, and this will be equal to 180 minus of angle of incidence plus angle of reflection. Or because we know that angle of incidence is equal to angle of reflection, so I can say that I is equal to R. So in place of R, if I write I only, then angle of deviation delta will be equal to 180 minus 2i. Or if I assume that this angle of incidence and angle of reflection is nothing but one angle which I give the same name as theta, then angle of deviation delta will be equal to 180 minus 2 theta. Why we are taking 180 here in angle of deviation? Because some of the angles constituted in a straight line is 180. So angle of deviation will be equal to 180 minus 2 theta. Okay. So questions can be asked based on glancing angle, based on angle of deviation, or based on loss of reflection. We need to know all these points thoroughly. Now, based on angle of incidence, this type of a question can be asked. The angle of incidence of a ray falling on a plane mirror is 45 degree. The deviation produced by the plane mirror is, see here, theta. The theta is given as 45 degree. We know that the angle of deviation is equal to 180 minus 2 theta, isn't it? Here, angle of incidence is given. That means theta is given, which is equal to 45 degree. We know that the angle of deviation produced by the plane mirror is delta, which is equal to 180 minus 2 theta. Just we can substitute the values here. Put theta is equal to 45 degree. Then angle of deviation delta will be equal to 180 minus 2 into 45. 2 into 45 is 90. So angle of deviation will be equal to 90 degree. Next expected question is, a ray of light is reflected at an angle of 15 degree. If the angle of incidence doubled, then the angle of reflection will be. Here what they are telling, they have given you the angle of reflection, that is 15 degree. Then they are telling that angle of incidence is doubled. Now one thing we know that angle of incidence is equal to angle of reflection, right? So if angle of incidence is doubled, then angle of reflection will be equal to 2y in place of I, isn't it? We know that angle of reflection is equal to angle of incidence. Now angle of incidence is doubled. So angle of reflection will become 2 times angle of incidence. With that we can find angle of reflection, right? So here the angle given is 15 degrees. So reflected ray will be at an angle 2 times that 15 degree, or the answer will be 30 degree. Okay. Here I would like to mention one more important point, which involves the number of images formed in a plane mirror. If there are 2 plane mirrors and if you have to find the number of images, then if you know the angle between those 2 plane mirrors, then you can find the number of images formed. The angle between those 2 plane mirrors is angle theta here. Okay. And number of images you can denote it by n. We shall solve numericals based on this formula, then you can understand what I am actually trying to tell you. For instance, just remember that number of images n is equal to 360 upon theta minus 1, where theta is the angle between the 2 plane mirrors. Okay, the angle with which the 2 plane mirrors are inclined, that is our theta. Another important point which you have to remember is that there is another formula. Other than 360 upon theta minus 1, there is another formula which is n is equal to 360 upon theta. Here theta is the angle between the 2 plane mirrors. Okay, you can give the symbol as A also, capital A also, theta or capital A. But the difference in using another formula is that the value of the angle. If that angle theta is even number, then without any tension you can use n is equal to 360 upon theta minus 1 or 360 upon a minus 1. But if that angle is odd number, then you have to use the formula n is equal to 360 upon a. Okay, I hope you are getting. See, even number means, see, for example, if your value of theta is 60 degree, 80 degree, 20 degree or 40 degree, then you use the formula n is equal to 360 upon a minus 1. Okay, or n is equal to 360 upon theta minus 1. But if the angle between the 2 plane mirrors is 30 degree, 50 degree, 90 degree, then you have to use the second formula, which is n is equal to 360 upon a or n is equal to 360 upon theta. Okay, these 2 conditions I told you. Means for even number you have to use the first formula, for odd number you have to use the second formula. But first formula is more important for us because there are 2 terms which you can find using this formula, right? If they ask you number of images, directly you substitute the value of the given angle theta or a and you find the number of images. But if in case they will give you the number of images and if they ask you the angle between the 2 plane mirrors, at that situation also you have to use first formula only, that is n is equal to 360 upon a minus 1 only. Okay, So first formula is important for us. We use second formula only in one condition, if the given angle between the two plane mirrors is odd. Okay. In the other case, where the angle is even, you have to use the first formula. Or if you have to find the angle between the two plane mirrors, you don't know at that time whether the angle which you will find will be even or odd, right? At that situation also you have to use the first formula only. Okay. Now to clear all your confusions, I will solve numericals based on three conditions. First condition, if the angle is even. Second condition, if the angle is odd. Third condition, if they are giving you number of images and they are telling you to find the angle between the plane mirrors. Means when you don't know whether the angle is odd or even, you will come to know only after you find it. In that situation also you have to use the first formula. I will show you the examples. Okay. See, for example, if you have a question like this. To get three images of a single object, one should have two plane mirrors inclined at an angle of. Here they have given you already n. They are telling that there are three images. They are telling you to find the angle between the two plane mirrors. Now you don't know the angle between the two plane mirrors is even or odd, right? In this situation, you have to use the first formula only. N is equal to 360 upon theta minus 1. You substitute n is equal to 3 because they have given you 3, right? Then you do some arithmetic and you get theta is equal to 90 degree. Okay. Ultimately, the answer is option C, 90 degree. So this is the one condition where you use n is equal to 360 upon theta minus 1. Next example. Two mirrors are kept inclined to each other at an angle of 60 degree and an object is placed between them. The total number of images formed is. Here what they have given? They have given you the angle between the two mirrors, which is 60 degree. Now you have to check whether it is a odd number or even number. 60 degree is an even number, right? Now they are telling you to find the number of images. Now you apply the first formula, the even number formula. What it is? Number of images equal to 360 upon theta minus 1. Just substitute. You will get 360 upon 60 minus 1. And 60 ones are 66. 6 minus 1 will be 5. So your answer will be number of images is equal to 5. Okay. Why we used this formula? Because the given angle is 60 degree and it is a even number. Okay. Now another example with the third condition. Two mirrors are inclined at an angle of 50 degree. Here what is the angle? 50 degree. Whether it is even or odd, it is odd number. For odd number, what is the formula we use? We use 360 upon theta. Directly 360 upon theta you can do and you can find number of images formed for an object which is placed between the two mirrors. Correct? Here you will get 5 ones, 5 sevens. Actually it will be 72, around 7.2 it will be. But there is nothing of decimal kind of thing, right? For number of images. So the near number is 7. So option D will be the right answer. Okay friends, I hope that now it is clear for you all how to use those two formulae. This is very important. I am expecting this type of a question in Karnataka TET this time. Okay. This was all about reflection. Now let's discuss all about refraction. After discussing about refraction, let us discuss few multiple choice questions based on reflection and refraction. After discussing the multiple choice questions, you will get one clear view of what type of questions can be asked in this time in Karnataka TET 2022. Okay, let's proceed. Now, what is refraction? See, when a light travels from one medium to another medium. For example, if there are two mediums, light is traveling through air and then it is falling on the surface of the glass. Then the speed of the light changes because here there are two mediums with different densities. Air is rarer medium here and because glass is denser than air, so glass is said to be the denser medium here. So whenever light passes from one medium to another medium, that is for example from rarer to denser medium or from denser to rarer medium, the speed of the light changes and also the light bends or the direction of the light changes when it enters into the another medium. Here for example air is rarer medium, right, and glass is denser medium. See, just you imagine, when light is moving through air, then it is moving freely because it is gas, right? As it enters into the glass, the other medium, which is a solid, here molecules are tightly packed, then the light will have sort of little bit of obstructions to pass, isn't it? So the speed of the light will decrease here, and also the light bends towards the normal while entering into the denser medium. For example, look at this picture. Here you can see that if I draw a normal, then as light touches the surface of the glass, it is bending towards the normal. Okay. Now, like reflection, refraction also follows certain laws. The first law is that the incident ray, the refracted ray and the normal to the interface of two transparent media, they all lie in the same plane. And the second law is well known as Snell's law of refraction. It states that the ratio of sine of angle of incidence to the sine of angle of refraction is equal to a constant, and that constant is known as refractive index or n. We sometimes also write as mu, the Greek letter. Okay. Usually we tell it as n. Now, if I say that the two mediums, the air and glass, for example, have two different refractive indices, then for air maybe it could be n1 and for glass it could be n2. Then instead of writing sin I by sin r is equal to n, I can also write as n1 sin I is equal to n2 sin r. And also, this refractive index of the medium, it depends on speed of light in the medium and speed of light in air. We know that the speed of light in air is 3 into 10 raised to 8 meters per second, right? So, this refractive index will be equal to speed of light in air, C, upon speed of light in the medium. About speed of light in the medium, it will be mentioned in the numerical. If they ask as a MCQ or in a 2-mark question, then you should be knowing the speed of the light in air, which is 3 into 10 raised to 8 meters per second. Then speed of light in the medium will be given. You can easily find the refractive index. Now, it is better to remember three values of refractive indices. First is of ice, then water and diamond. At 0 degrees Celsius, the ice is having the refractive index of 1.3 and water has 1.33, diamond has 2.419. With this table, you can infer that ice has the lowest refractive index and diamond has the highest refractive index. All this can be asked. See, whatever I am teaching, whatever I am discussing in this video or my any other previous videos, every line is important. Especially in this video, every line is important because anything could be framed as a question and they can ask you in a MCQ or as a descriptive question of 2 marks. Okay. Now we are saying that if light is passing from a rarer medium to a denser medium we took it as a glass now. That glass, it could be a slab, it could be a prism also, right? Then even in prism, if the light falls on the surface of it, then refraction should take place and the change in direction should happen and the speed of light should change, isn't it? Now, whether this prism surface is a straight line or it is curved, this should happen, right? Now, if I use both these things, the prism and the slab, and then arrange it in a proper way, then I can create what is called as lens, a convex lens and a concave lens. Let's not worry about the lenses now. I will take one separate class to teach lenses. Okay. Here I am just giving you an idea about how is the application of refraction, how it is used. So the refraction is biggest application for the concave and convex lenses. Okay. So about convex lenses and concave lenses, I will make another lecture. So we will not discuss about it right now. Now let me solve few questions based on reflection and refraction. This will give you more clear idea on what type of questions can be asked on these topics, right? So the question is, which statement is true for the reflection of light? You have to read 4 statements carefully. You can pause the video now and you can read, okay? But for instance, I am giving you the right answer here. The option is angle of incidence is equal to angle of reflection, which is the first law. Correct? You all know it, right? If you have attended this class from the starting, you will easily take the right answer. Okay, next question. The laws of reflection hold good for plane mirror, concave mirror, convex mirror, all mirrors. See, laws of reflection, they hold good for all type of mirrors. Whatever their shape is, no problem. The laws of reflection will hold good. That's why option D is the right answer. Okay. Next question. Light travels fastest in. This you should know. Light travels fastest in air and the velocity of the light in air will be 3 into 10 to the power 8 meter per second. Okay. In water, glass and diamond, the velocity of the light will become lesser. Okay. Because you know it, right? Because see, diamond it is hardest. Velocity will decrease only. In water and glass it will be little more, but it will be less than air, right? If I want to put it in some order, first good velocity will be in air. Next should be in water. Next should be in glass. Next should be in diamond. How I told this? I told with the texture of the material. Okay. Air is gas. Water is liquid. Glass is solid. Diamond is harder solid. Okay. Just you can just imagine. You will come to know what I am trying to tell. Okay. Next question. The deviation of light ray from its path when it travels from one transparent medium to another transparent medium is called. Of course, it is refraction. Next question. They can ask questions in the type of fill-ups also, but they will give you 4 multiple choice options below. Okay. Here I am giving direct fill-ups. Okay. Directly you have to guess the answer and write. Question is, when light falls on a surface and bounces back to the medium, the phenomena is called. Bounces back means it should be reflection. Correct? Next question. According to laws of reflection, the angle of incidence is equal to angle of course, now you know the answer. Angle of reflection. See, for both the questions, answer is one only, reflection only. So, they can ask any type of questions in a twisted way. Okay. Next question. This is a multiple choice question. Image formed by a plane mirror is, at the starting of this class I have explained you, image formed by a plane mirror is virtual and erect. Okay. So, okay friends, this finishes our class of reflection and refraction based on Karnataka TET syllabus. In the next lecture, I will try to finish mirrors, and then in the third lecture, I will finish lenses. Okay. So, your portion of the optics in your Karnataka TET syllabus will be completed by that time. Okay. So, I really hope that this lecture will help you. And as I always say, you have less time. Please do work hard. Practice whatever I am discussing. Each and every point in my lectures are very, very important. Okay. You don't need to skip any part of my lectures, especially which I am making for Karnataka TET and HSTR. Okay. And before signing off, I would like to remind you all, please do like, share and subscribe to my channel. And if you have any queries, you can write to me in comment section or in Telegram channel. The link of the Telegram channel will be given in the description. Okay. And also I have made many lectures based on Karnataka TET, science and maths lectures. I'll give the playlist link in the description. You can go and check out the playlist and try to watch each and every lecture from that playlist, because it is very, very, very important playlist for Karnataka TET aspirants. See, if you attend my classes, you don't need to check out other textbooks also. You don't need to go to the other sources also to learn. Okay. But you have to follow all my classes strictly. Without missing, you have to watch them, practice them, make notes and do good revision. Okay, friends. Okay, then I'll sign off. Thank you. All the best. Bye.